Question 10, we are using true bearing, but this time it's an application of it where we have to calculate distance and area. But first we have to try and visualize this diagram and draw it out, and then try and work out what part A and B have to say. So let's start by, the question says, 3 immunity dolls are hidden on an island for a TV reality game. Idle B is 450 meters on a bearing of 72 degrees true north from idle A. We have idle C, which is 885 meters on a bearing of 75 degrees southeast from idle A. So I want to try and plot these. Okay, so what I'll do first is I'll put this one maybe right here in the center. I want to know 72 degrees true north from idle A. So let's start there. I always look at this part first. So 72 degrees true north from idle A. So I will mark this spot as A. So 72 degrees, that's 90, so it has to be within there. So I'll put that there. Call that 72 degrees. And the distance is 450 meters. To that point we will call B. Okay, now let's read idle C, the one highlighted in blue. So idle C is 885 meters on a bearing of 75 degrees southeast from idle A. Okay, so again from idle A we want to know 75 degrees, but this time not true north from south, we know that's east. So so this time anti-clockwise this way, southeast is at 75 degrees. Again, something similar where we have something like that. That's 75 degrees, and we will call that point C, and it is 885 meters away from A. So that's the most important stage, is getting those done there. And then part A says calculate the distance between immunity dolls B and C. So calculate the distance between B and C to 2 decimal places. So we are looking for the distance between B and C to 2 decimal places. Okay, so what we need to realize is what rule we're going to use. So we have two sides, so what we have is we've got that, we have this length here, and in terms of angles we could get what that angle is there, and if we can get that, we can use the cosine rule to find out what our missing length BC is. Okay, to get, first of all, to get what that angle is, you will do 180 degrees, because angles in a straight line there is 180. So 75 plus 72, and if we take 180 from that, we will get our answer. So I get 33 degrees, and that's that angle there, which is 33 degrees. So I'll just remove this line here so we can see. Alright, so now I have my angle of 33 degrees and my two sides. So now even if you're not sure what rule to use, I told you it's the cosine rule, but if you're not sure, have a look at your formula sheet. And you know it's a triangle, so it'll be something to do with trigonometry. So what rule here can you use where you have two angles, two sides and one angle? And that here you can see that if you have two sides and one angle, right, so you've got the two sides there, one angle, you can find that other missing side. If it was a right angled triangle, then we could have used Pythagoras' theorem, but since it's not, we cannot use that. Okay, so we'll go back. So here using the cosine rule, this one says that c squared is equal to a squared plus b squared minus 2ab cos c. So the capital letter is the angle, lowercase letters are the actual sides. What I'll do is I'll draw my triangle here again. I've got 450 meters as AB, AC is 885 meters, and my angle is 33 degrees. Okay, so I will now just label these. So this is usually across the angle A, we label that A. Opposite the angle C, we label that C. And opposite the angle B, we label that B. Now, this could happen to you where you see the unknown side is A, but in the cosine rule, it says C squared there. So I've got to make some changes to my equation. So you see where it's C there, you can see the angle is C, so you kind of start there. So we have the angle A, right? So that is what's going to replace the cos C. Okay, so I will have A squared at the very beginning. A squared is equal to C squared plus B squared. So wherever I have C, I've replaced A, and where is A, I've put C, minus 2CB cos A. So I've made my cosine rule fit my labeling on my triangle, and I can now look for A. Okay, so let's try and solve it. I've got A squared is equal to 450 squared plus 885 squared minus 2 times 450 times 885 cos 33. Now be careful when you're putting this in the calculator. I'd advise using brackets so you don't make any mistakes. And when I did that, I got A squared to be 317,723.8 0.8926. Now you don't stop there because you need to get rid of the square, so you do the square root of the answer that we got. And your answer is 563.67 meters, and that kind of fits with our values. And so that's our answer for part A. So that's how I did A. And now let's look at part B. So it says calculate the triangular area to the nearest meter between immunity dolls A, B, and C. So that triangle A, B, and C is what we're looking at. And so we just want the area of that triangle. Okay. I'll come over here and do it at the bottom. Oops. So area of triangle ABC to the nearest meter. So I have my triangle here, ABC, 33 degrees, 450 meters, and 885 meters here. Yep, I have figured out that my side here is 563.67 meters. So there are multiple ways I could do this. Area of the triangle, actually two ways. There's the long way, which is using Heron's formula. So you could use that side, and that side, using the formula, using the semi-perimeter, and then using that semi-perimeter to find the area. Or we could use a half AB sine C to find the area using that formula. I'll show you where they are on the formula sheet. So for area, so either this area here or Heron's formula, which is a bit at the top here somewhere, Heron's rule here, where you'd be using all three sides to find the area. Whereas here we have two sides and an angle. So I'll use that one with the sign. So area, a half. This one will be BC sine A. Just remember that's A, that's B, that's C. So then if I plug in my values, a half times 885 times 450 sine 33, and I will get my area as 108,451.25 square meters, but it says to the nearest meter. So my answer should be 108,451 square meters. And so that's my final answer for part B.